In the last part of section 2.5, we discussed percentiles. A percentile is another way of splitting up data into groups so that the location of one piece of data can be viewed in terms of how it compares to others. So with quartiles, we split data up into 4 groups. With percentiles, we divide the data up into 100 groups, with each group containing 1% of the data. And you will commonly hear people speaking about percentiles with things like standardized test results, or when you go to the pediatrician as a kid, they very often will put you on a growth chart and show you what percentile you are for your height and your weight. The way that you calculate the percentile for a particular piece of data is you take the number of values less than the piece of data, divide it by the total number of values, and multiply by 100. And you're always going to round that to the nearest whole number percentile. So the percentile rank is going to tell you the percent of the data values that are below a particular value. And it's that close relationship to percents that makes it useful and relatively easy for people to understand. Example 6 uses this data set again, the tuition costs in thousands of dollars for 25 liberal arts colleges. And we're going to find the percentile that corresponds to a tuition of $34,000, and then we'll interpret that answer. So the first thing that you need is to have your data set put in order. I've written the organized data set in red. So if we are looking to determine the percentile rank for $34,000, the first thing we need to note is that the data has been shortened to be in thousands. So really, this corresponds to the number 34 in our data set. And using the formula for the percentile rank, the percentile for 34 will be equal to, we're going to count the number of data entries less than 34. So you can see that's why it's helpful to put the data in order, because now I locate where 34 is. And I start counting the pieces of data less than that number. So I have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 numbers below 34 out of, this is a data set with 25 pieces of data. And then I will always multiply that by 100. And that gives me 32. So the percentile rank for this data is 32. Therefore, the tuition cost of $34,000 corresponds to the 32nd percentile. Now, when you're asked to interpret that answer, you need to explain what percentile means. So because this is the 32nd percentile, a percentile always tells you there's 2 ways of looking at it. The percent of the data that your score is higher than, or you can think of it the other way, the percentage of data below you. So if 34,000 corresponds to the 32nd percentile, then 32% of the tuition costs are below 34,000. In example 5, we're going to look at our first Ogive graph. So what an Ogive graph is it's a cumulative frequency histogram. So that's where the data accumulates and the bars get taller as you move from left to right. In this case, these dots represent the heights of individual bars, and it's as if you erased the bars, left only the dots, and connected them to see a trend. So the ogive at the right represents the cumulative frequency distribution for SAT scores of college-bound students in a recent year. What score represents the 80th percentile? And then interpret your answer. Begin by finding 80 on the percentile axis, reading across until you hit the data. Once you find the corresponding point, you're going to read down on the graph, estimate the SAT score that corresponds to this percentile. So it looks like it's about halfway between 1200 and 1300. So I might say something like a score of 1250 represents the 80th percentile. For the interpretation, this means that 80% of students who took this SAT scored below 1250. And that's very often standardized tests are reported that way so that you know how you did in comparison to others, which is why this is a measure of position.